Welcome everyone again to my channel, and today we are going to finish sets, and we have our last lesson, which is lesson 3, which we are going to talk about sets. So welcome again to my channel, and before you start, don't forget to like and follow the channel. I've seen most of you are just watching, but you are not following the channel, so don't forget to follow the channel. So in today's video, we are going to talk about our lesson 3, and we are going to start with the laws of set algebra. What are the laws of set algebra? So our first law for algebra is that one there, which is idempotent laws. I don't know that word. Yeah, that's our first law of algebra. Now, what does this law say? What does this law say? So this is just a law that states it has two rules. The first one is when you have A union A, what are you going to have? The answer is what? A. So that's the first example of this law. Another one is it's A. Yeah, A. And another one is A intersection A is what? Is A also. Yeah. So that's just the idempotent what laws. For example, set A has 1, 2, 3. So what is A union A? So it's just A. The answer is just A. What about A intersection A? It's just A. The same elements also. We have another law. Now there's another law which we say commutative law. So what is this commutative law? Commutative law is just a law which is just stating that the order doesn't matter. So when you say the order doesn't matter, for example, when you write A union B, this is the same as when you start with B union A. So that's just what we say when we say the order doesn't matter. That is a commutative law. The order doesn't matter. You can start with A, you can start with B. The answer is still the same. Or, for example, A intersection B is the same as B intersection what? Intersection A. So that's commutative law. Let's go to another law, which is associative laws. Now, this associative is somehow similar to commutative, but the only difference is that for this one, mostly you find it's 3 sets. For example, you can say A union, and mostly here we usually have brackets. So when you can say A union B, we put it in brackets. Union C, this one. Then this one is the same as also. Even if you can just start with A here, then you put union B union what? Union C. So this one is also the same as this. As you can see, it's somehow similar. It's the order, doesn't matter, but even the grouping. Yeah, you can start with A union B, or you can start with A union B union C, you put it together. That is associative law. So that's our third law. Let's go to our fourth law, which is distributive laws. So for distribution also, it's a little bit similar like associative, but it has a difference. So for distributive, you find the example that I can give is A union, we put the brackets, B intersection C. This is the same as you can see, this one is similar like that one, but we can put this we can distribute this. How can we do it? We can say A union B. As you can see that one, A union B, we put an intersection here, intersection A union C. So these are the same. This one, and this one, they're just the same. A union B intersection C is just equal to A union B intersection A union C. Yeah. So you can prove this one on your own. You can try to have a set A and set B and set C. Try to find the elements of set A union B and also the elements of A union C. Then find the intersection of those sets. The next one is identity law. Identity law. So let's talk about this identity law. So for this one, we are just trying to, okay, let's do it using an example. We can have an example of we have set A union an empty set. We talked of an empty set and a set having no elements. A union empty set. The answer that you are going to have is just set A. Say set A union empty set. The answer is just A. A intersection empty set. The answer is just what? The answer is just empty set. What are you observing here? So an identity law, this is just a law whereby when you try to operate two sets, the answer that you are going to have is one of the sets. For example, A union empty, the answer that you have got is set A. A intersection empty set, the answer that you have got is what? Empty set. Let's do another example. We can have A union universal set. A union universal set, the answer is just what? The answer is just universal set again. What about A intersection universal set? The answer that we are going to have is what? The answer that we are going to have is what? Is the same set A. So as we can see now, this is what we call identity law. Yeah, this is what we call an identity law. So let's go to another laws of algebra of the sets. So let's look at another law, second last law, which is complement law. So this is just a law whereby a complement is involved. Last time we talked of a complement. Yeah, something which is eliminating some elements which are not in that set. So the example that we can give here is, for example, we have set A union A complement. So when you say A union A complement, the answer that you are just going to have there is what? Universal set. Yeah, so these laws you can prove them. Yeah, for example, you have a Venn diagram here. This is universal set. We have set A inside. We have this is set A. Now when we say A is everything that is inside. So all the elements that are inside, it's this one. We shade it. Since union includes everything, we shade it. What about A complement? Elements that are not in A, we shade everything that is not in A. Everything. At the end, you are going to have to find that everything that is shaded is just universal set. That is another example of complement set. This one. Another one is A intersection A complement. What's the answer? We have A, another Venn diagram. Another Venn diagram. There is A here. We are saying A, it's this one. Intersection A complement. A complement is this one. Everything that is not inside. So what elements are common? For example, we have 1 here and we have 2. Let's say A is equal to what? What are the elements in A? 1. What about A complement? A complement, it's what? 2. Now let's intersect. Let's say A intersection A complement. What are we going to have? What's common? Nothing. So it's an empty set. So even here, A intersection A complement is just what? An empty set. What else? A complement, we open of complement. So we are complementing the A complement again. So what does this mean? We say A complement. Let's start with A complement. Here, using this. A complement here is equal to what? Is equal to 2. Is equal to 2. Everything that is not in A. What about the complement of A complement? So what's not in A complement? It's just 1. This one. So we are going to find that the set that we are going to have complement of A complement is A. So a complement of a complement is just what? It's just set A. That's another law, which is complement law. Those are the examples. Another set that we can have is another example that we can have is complement of universal set. When you say complement of universal set, what's not in universal set? It's an empty set. Look at this. This is a universal set. What's not in this one? It's an empty set. So here we are going to have what? Empty set. What else? Another example that we can give on complement law is A intersection B complement. So A intersection B complement is the same as A complement union B complement. So this is just the same. A intersection B, the complement of A intersection B is the same as A complement union B complement. So that's the last example on what? On complement law. So let's look at an last law, which is De Morgan's law. Oh, sorry guys. In fact, this one that I was saying, A intersection B complement of this is equal to A complement union B complement. That's the last law, which is De Morgan's law. That's the last law, which is De Morgan's law. So just write it somewhere. De Morgan's what? De Morgan's law. This one. Yeah. So from that one, we are done with the laws of set algebra. Alright guys, so we'll stop here and see you in the next video. So we are going to end it in the other video. Yeah, so thank you guys for watching, and as usual, don't forget to subscribe.